Hi, welcome to the assignment number 7, problem number 7. Here, the problem is given a linked list, where every node represents a linked list and contains two pointers of its type. A next pointer to its next node, a bottom pointer to a linked list where this node is head. We have to flatten this to basically this is the input, which is nothing but we call it as a 2D linked list. That means the linked list usually it points to the right, but for this linked list it also points to the downwards also, so that we call it as a 2D linked list. And here the problem is we have to flatten the given linked list into the sorted order. Like, if we see, first of all, what we have to do means we have to print 5, and we will compare with 7 is the next one, so it will have to print 7, then 8, then 10. After 8 we are going to print 10, and then 19 and 20 and 22, 28, 30 and 35, 40, 45, 50. So it is going to be the resulted output. That means sorted linked list. We have to flatten all the 2D linked list. So here we are going to solve this problem using this solution. Let's see how to do this. First of all, we are going to take a linked list node which has the data and the two pointers, which is going to point. One is right and another one is the down. This is each node, it has two pointers like and we're going to take one more utility function here to insert new node into the beginning of the linked list. It is going to insert new node to the beginning of the linked list. I mean, that means first, if it is going to start here, it is going to insert next this one, like this. This utility function is using for that one. If we see, the new node is going to node and malloc size of node, and new node to the right is equal to null, then put into the node. New node data is equal to data. If it is right is null, then new node will put into the node. Then this is the function for that. The next function is function to print nodes into flattened linked list. That means it is going to print the data into this format. This function is for that one. And here comes the main function. So what is our approach here to solve this problem is we are going to merge two sorted linked list into flatten first. So by using this merge method, we are going to call the merge method recursively to finish all the linked list connected to the right and down side of the linked list. What we are going to see, if a first linked list is empty, here we are first checking the conditions. We are taking two nodes, like two linked list A and B. So if that means if we see this is A and this is B linked list, then we are going to check if A is equal to null or B is equal to null, then we return A or B. We don't have to extend the problem. Then if if A's data is less than B's data, then the result will be A, and the result down merge result down is going to merge with this number again. Then it is calling recursively to merge these two linked list. So if we see, it is compared with 5 less than 10, so it is going to print 5 first, and then it will compare with the 7, then it will all compare with the 8, so 7 8, and it will compare with the 10, so it will print this value this time, like b value, so 10, and result down, and it will call this recursively, and it will compare 20. Yeah, like this it is going to use this function to flatten this thing. So next what we're going to do means, by using this merge method, we are calling actual flatten function here, not root. So what we are going to do here means, if root is null, we are going to take this, if it is a root, then we will compare it with the right value. By doing this, we are going to merge this linked list. This is the main function. It is also calling recursively to flatten the linked list, and then the result merge root is root of merge. I mean, here we are going to merge this merge method is to merge two linked list, and this flatten, what we here doing means, it is going to call all the linked list, the down linked list to the right. We are going to use this one to merge all the linked list by calling this merge method, and the flatten method also recursively. Here we see the flatten method root to the right. So here we are going to take the root to the right, and we are going to return that merge method. Finally we are going to get the results 2022, and then it is going to call 28, 30, 35, 40, 45, and 50. So this is the solution for this flatten given linked list method. Thank you.